This is part 7 in a series of videos in which I'm attempting to repair this HH Tiger computer. And initially I found an issue with the power supply that had partly failed, and since then I've been finding a lot of failed components. And what I've now been doing is going around with the Logic analyzer that I'm developing and using that to test the bulk of the devices on the board. And one thing that surprised me is again the number of failed components on this board. It's not that old, so I wouldn't have expected quite so many of these components to failed, and judging by the date codes they were mostly the originals, so it looks like it's had a single event that's caused a lot of these failures. Now it could have been the failure of the supply, which is what I initially assumed, but what I've discovered while I've been going around testing this and having reviewed the earlier videos is, if you have watched the first video in this series when I took this apart, I think somebody even commented that I only had 2 of the memory boards fitted, and I think someone said one was missing, and I didn't mention it at the time, but I'd actually taken one out. What I tend to do early on in a project, and before I power anything up, I give it a good clean, but what I tend to do is take out or exchange or swap any rare parts. Now, for example, I think the same comment also said that I'd changed the video processor chip, which I had. I put in place an alternative. These are easier to get, a lot cheaper, and what I tend to do is anything that's rare or hard to get, I'll put an alternate in so I don't damage the original if there is an issue with the supplies when I first hook it up. And I tend to do that with everything, the CPU, anything I've got a cheaper alternative for. Now these video chips aren't particularly expensive, but they are quite rare, so I wanted to protect that in the event that there was something wrong. But when I found so many memory chip failures, now memory chip failures on their own is not that unusual, and it could have been caused by the fact that the 5-volt connector had broken. And if the memory chips are run with a 5-volt disconnected, but the minus and plus 12 volts, that's minus 5 volt and plus 12 volt supplies connected, it can destroy them. They'll develop internal shorts and it will prevent them from working. But that didn't seem to be the case here, and also there were too many other failed components for that to be the case. Now one thing that I did then realise is when I took the card out, that, as I say, someone commented it was missing. I'd actually taken it out, and the reason I took it out is it wasn't plugged in correctly. It was offset on the connectors, and I didn't think that much of it at the time. I just removed it, and I wasn't really going to test it with all the boards in any way, so I just got it out of the way, and I carried on removing things until I had what I thought was a safe startup point. But then it did occur to me that having this offset may have caused the major issue. Now, when I design equipment, if I have an edge connector, I usually key it so you can only put it in the right way around and in the right position. But one thing I've noticed with these is they're not keyed. Usually you'll have one pin that's not used, and you remove the pin from the header, and you put a blanking plug inside these, and it stops you being able to plug it in. It's physically impossible to plug it in the wrong location. This doesn't have any, so in other words, you can plug this in anywhere you want. You could probably even plug it in the wrong way around completely. And if I do have a situation like this where I don't have a choice, what I normally do is I arrange the pin out so if it is offset by 1, 2 or 3 pins either way, it doesn't do any harm. But tracing through the circuit on this, what I realised is that if you offset this by 1 pin in the direction this was plugged in incorrectly, what it does is it connects the 12 volt rail from the power supply directly onto the 5 volt rail on the main board. In other words, it's trying to feed 12 volts into the main board. Now I can't guarantee that's what caused the problem, because I'd be kind of surprised if the 12 volt supply could supply enough current to do too much damage, but it does seem quite likely that it would do at least some damage, especially to the more sensitive devices. And that could explain why we're getting so many failures on this board. Could be something else, but that does seem like quite a high probability as to one of the issues that this board has. So anyway, I've been going around doing various testing, and I thought again I'd show some more use of the Logic Comparitor and how it's used and how much time it can save. Now on this board most of the ICs are plugged in, so it's still quicker using this than it is swapping them, but at least using Logic Comparitor it shows up whether the devices on the board are doing what they should do, and also some of the devices are soldered in, so again this comes in very useful for testing devices that are not easily removable. So what I've done so far is using the same module board. I tested all the 7400 devices, swapped any that were faulty. So what I've done now is swap the 7400 with a 7408. I can use the same configuration on the module cards. I'm using the same module card because the pinout of the 7408 is effectively the same as the pinout on the 7400. So I can use the same configuration of module card. It's a different logic device of course, but the pinouts are effectively the same. So all I have to do is just swap the device and the rest of it can stay exactly as it is. I can then swap this with a 7432, again different logic device, but the pinouts are the same. So I can use the same module card again. So as I've said previously, you don't need that many module cards, it's just making sure you have the right device. Okay, so I've got it hooked up to the first 7408. I'll power it up and we can see we're not getting any error lights. So I'll power it off and clip it onto the next 7408. Power it back up. And again, all the lights have gone out, so we know that this device is working. Power it back off. You can see when I power it off we do get error lights, but that's to be expected. We've got the Logic Comparitor powered up, and naturally the outputs on the unit under test board are not now the same because there's no power going to it. So I'll turn the tester off, clip this onto the next device to test. Okay, so I'll power the tester up, I'll power the board up, and as we can see, make sure that's properly connected, as we can see we're getting quite a few error lights, and also as you can probably see it's the outputs that are showing as faulty. So we have 3 of the gates on this device are giving the incorrect outputs, and this is where this starts getting more useful of course, because this particular IC is soldered to the board. So naturally what we have here is a faulty IC, so that one will need to be changed. So I'll change that in a few minutes and retest it. What I'll do now is swap the 7408 with a 7432, and I can then test all these 7432s again using exactly the same module card. And you do tend to find on most boards that designers tend to have favourite devices that they use, and there isn't usually that many different devices on a single board. I think there's about 7 or 8 7432s on this particular board and about 6 or 7 08s. So I'll do that, I'll get the rest of these tested, and I'll come back once I've done that and test the replacement chip to make sure that this did correctly identify a faulty device. You can see it's a fairly solid fault indication, so it's not a poor connection. It does look like a genuinely faulty chip. Okay, so I've replaced the 7408 and it's running, and as you can see the error indications have gone away. Most of the rest of the ICs that I've tested were fine. One thing that has come up as part of this testing, and it's really the reason that I'm doing the testing on the Logic Comparitor, is I was getting a few false readings on one particular 7032, and it's the one that controls the CAS signal going into the main system DRAMs. And the reason it was giving false indications is it has very weird arrangements on its inputs. It's not fed directly from another logic device, it's fed from one device through a resistor and another device through a capacitor, and on the other side of the capacitor it's fed from a device that has open collector outputs. So I've got no idea what the designer was thinking with this. It's a very flaky arrangement. It's obviously designed to allow the merging of two signals to generate a CAS, but it's a very poor design, and I found that on several aspects of this design. It's very poor in the way certain aspects have been designed. It's like they designed the system and then couldn't quite figure out how to make certain bits work, so just threw something at it to try and make it work, almost out of desperation, it seems, from some of the design aspects. And the reason this was giving false indications on the Logic Comparitor is because it results in some very strange signals going into the inputs of the gate. They're fairly slow rising edges, and also they are very noisy. It's multiple stepped inputs, and so it looks like, to cater for this sort of thing, the capacitors I mentioned, the filter capacitors I mentioned on the Logic Comparitor, may need to be raised from 470 picofarads up to maybe 680 picofarads. I'll test that and see if it resolves the problem. This is probably not something you'll come across that often. I've seen this sort of thing now and again, but it is fairly rare. But to be honest, it is a fault situation. Having slow rising edges going into a TTL gate is a very bad thing, and I'm kind of surprised it worked reliably at all. It's not even a Schmidt gate type device, so that's a bit strange. So I'm not quite sure what the thinking was behind that, but at any rate it does help to test the Logic Comparitor and give it a very good workout. So very quickly is 10 minutes to test all the 7400, 7408s and 7432s on the board, and as you can see, I've changed the one that was faulty. It's now working. I'll go through the rest of the standard Logic devices doing the same thing, and by the time I've done that, hopefully I'll be left with far fewer faults and maybe a bit more activity on the system. All I'm getting at the moment is the cursor on the display, and that's generated by the video output chip. It just generates an input into the memory RAM, and that generates the cursor on the screen, but there's nothing else being merged with that. There's usually 3 planes on this video output, and none of the 3 planes are outputting any video other than the cursor. Everything else seems to be fairly dead, even though overall the circuit seems to be running. I'm getting activity now on both sides. Initially the Z80 wouldn't boot up at all, and that was because of an issue with the DRAM. As I say, I wasn't getting a CAS signal. I've dealt with that. I'm now getting a CAS signal. Whether it's right or not, I'm still not quite certain. Also, I'm not 100% certain that the replacement DMA chip I got is working as it should. It's the only replacement I purchased, so I might have to get another one of those to see if this particular one is a faulty one. But I'm getting there. Overall the circuit's starting to come to life. I had to replace the 2 sockets down here next to where the battery was. They were very badly corroded, and there was no way I could recover the sockets. Now, someone did leave a comment asking how I go about cleaning the sockets, so I just thought I'd very quickly include that in this video. If it's not the sort of thing you're interested in, then please ignore the rest of this video, but I just thought I'd give a quick demonstration as to how I go about cleaning the pins on these IC sockets. Okay, so step 1 of course is to remove the IC. Now this technique won't work with all sorts of IC sockets. It will only work with the ones where the pins are pushed in from the bottom. If they're pushed in from the top, you can't do this because you can't get the housing off. But a lot of the older sockets were like this, and you can tell if you can see the entire pin on both sides, then you won't be able to get it out. If you can only see the pin through holes like this, then chances are this technique will work. And all you need to do is just very carefully ease up the housing on the socket. So be really careful, these are very easy to break, and what you're trying to do is to just ease it up off the pins. Although I'm levering the board here, I'm using something that's not going to damage the track, so don't use anything metallic. Make sure it's something that is a lot softer than the tracks are on the board. This will pop off fairly easily, and then once you've got this off, you get access to the pins. What I then do is to paint them with something such as evaporust. I don't use the gel because that's hard to clean off. What I tend to do is just put a piece of kitchen towel or something over it, and then I'll drench the kitchen towel in evaporust. I'll leave it for 3 or 4 hours. I tend to do all the sockets I'm going to do at once, and then once that's had a chance to work, take the kitchen towel off, have a look if it needs longer, put it back on, put some more evaporust on, and leave it until as much corrosion has gone as I can get rid of. This is rust we're talking about rather than the green corrosion. Once you've got rid of the rust, I'll give it a good rinse under the tap, a bit of detergent to get the evaporust off. Give it a good blow with compressed air to get the remainder of the dirt off, and what I then do is use a fine brush, fairly stiff but very fine bristles, and I use IPA to give the pins a very good clean. I don't use any sort of abrasive, simply because I don't want to take the plating off of the pins. That would make things even worse. Sometimes you'll get a pin that might be too badly corroded to clean, in which case what you can do at this point is simply lift the pin out, put the soldering iron on the back, lift the pin out, get a replacement socket of course, and then put the pin into the socket before you put the housing back on. Once you've got it all clean and you got rid of all the corrosion that you can, then it's just a case of getting the housing, put it back over the pins, make sure all the pins are properly located in the housing before you try pressing it down, and then evenly, gentle pressure, just give it a press down, it'll go back down. Make sure it's down evenly all the way around, and then the socket is good to go. It's a very good way of cleaning these sockets. As I say, it won't work with all types, but sockets like this, it works very well. The only ones on here I couldn't recover are the ones that were over by the battery that had leaked, and they were too badly corroded, and they were kind of snapping off as I was removing the housing, and they were pretty much disintegrated internally, so I just replaced the sockets. This is also a good way of actually removing sockets. If you want to swap them, just pop the housing off, pull the pins out one at a time, and then use desolder wick to get rid of the remaining solder. It's a lot easier than trying to get the entire socket out in one go, which can damage the tracks or pull the pads up. Okay, so I'm sure everyone has their own way of doing that, but that's the way I go about cleaning the sockets, and it does work fairly well. So in the next video I'll hopefully have made a bit of progress on getting rid of all the faulty devices, or at least the standard Logic devices that are faulty. I'm going to concentrate on getting just one of the memory boards going for now. It will only give me one plane on the video, but it will allow me to at least get the video part of the system up and running. I don't think they're interdependent. If anyone knows different, then please let me know. But I think they just supply the 3 red, green, blue planes for the video output, and as I say, I'm just using this one here to try and get at least one plane working. So just for completeness, this is the IC that I took out. This is the 7408 that the Logic Comparitor identified as having a fault, and as you can see, the IC tester also identifies it as being faulty. You can't always test the devices like this. Some devices aren't supported by this, and also of course we were able to test it before we removed it from the board.